All right, everybody, welcome to the first Data Engineers Lunch, part of the Data Wranglers DC meetup. We have not had a Data Wranglers DC meetup event in a while, so we might as well get started now. Today's focus will be to look at what a data engineering roadmap looks like for a person. There are actually data engineering roadmaps for people and for systems and for companies. Well, today we're going to talk about how a person can go from being a newbie or novice to a ninja in data engineering. And actually, as you'll notice, there's constant learning beyond what I'm going to outline. This is part of a meetup in which we have organizers and co-organizers. Akli is the co-organizer. If you're interested in helping or becoming a co-organizer or being a speaker, please reach out to Akli. We are part of the Data Community DC, a diverse group of people, background, gender, religion, and welcome people from various different backgrounds to come and present. We are one of many meetups in this community. Data Science DC, Data Visualization DC, Statistical Seminars DC, Full Stack DC, Nova Data Science, and you name it, we have a lot of folks here. We used to have a thing called Business Intelligence DC, and I think that went away. We may want to get that back. What do we cover here? We cover the processing or engineering of data. Data engineering, data wrangling is a term that's, data wrangling specifically is a term that's used in data science, but the formal job generally is data engineer. You don't see a job description for data wrangler. But data wrangling is like, wrangling a steer, getting it under control. Raw data generally does not make anybody's life easier. Just looking at raw data, you can't do anything. You can't act on raw data for the purposes of, let's say, business intelligence, dashboards, data exploration, or let's say machine learning. You have to clean the data. You have to potentially engineer features such that the model can pick it up and use it. Data engineering. If there's anybody, who is a data engineer, or since this is our first one, I think most people can chime in a little bit. Just take who you are and what your last experience is with data engineering. So anybody, I'm just going to get a couple of people to say hi. Arpin, you've been doing some stuff. Share your face, and yeah, I'll just share my face, so I don't know why I did that. There you go.
Hi, I'm Arpin. Sort of new to data engineering. I've worked a little bit with Presto and Spark, but recently I've been working more hands-on with Spark and learning data transformations, how to work with Spark and Scala, and also learning running jobs against Cassandra, specifically Astra. Yeah.
Great. Pramod.
Yeah, I have been working with Spark, basically with Spark, PySpark, and then on the Elastic Stack. That's all.
Great. And Obi.
Yeah, I've also been doing some Spark stuff, specifically a bunch of stuff related to machine learning. And I also have some experience with machine learning outside of that, using the normal Python libraries and MATLAB stuff and R that's available.
Great, very cool. My experience with data engineering is recently used a awk script to take a bunch of IDs to make a SQL file. And if you've never used awk or sed, in Unix, that is also data engineering. Does not have to be all Spark or Python. If you have a question, ask it. If you know something, go ahead and share it in the chat, or just come on camera and wave, and I can see the screen and I can see your faces here. DataStack is a sponsor. So is GW. We have a couple local sponsors, as well as institutional sponsors. This is the first one. We have just a few announcements. A lot of community events on Data Community DC. There's a few data engineering type events that Anand, my company, is putting together. Pretty much all of them are on Spark, I think. But welcome to join any of those events. And that's just the intro deck. As with the other meetup, Cassandra Lunch, I'm going to use this outline to have a history of what we've spoken about, and then have a backlog. So at the end of today's session, or near the end of today's sessions, I'll ask folks to see who, what you guys want to talk about next time. All right, I'm going to close a bunch of these things. There we go. Make this a little bit faster. So what is data engineering? Data engineering is a specialization of software engineering, and it's hard to somebody who has not been in data, they think of data engineering as just one aspect of the job, when it's reality, it's beyond that, especially because the world is heavily using data from a lot of different sources. Data engineers need to be more than just, quote, ETL people or data wranglers. They need to think about the whole operation of the system. The path to data engineering starts with just being able to program. I was even going to put in here, actually, that would go under scripting. I would say things like thread. Even there's a tool called JQ. Programming in data engineering is about understanding how to take one type of data, clean it, process it, flatten it, expand it, whatever you call it. And so some of the programming languages that work well with the size of data today is Python, because it can work, as Obi mentioned, on, quote, normal scale, or it can scale in Spark or in Dask. It can scale at a very large scale as well. Scala is a programming language that, again, you can use in a variety of ways, like Akka or Spark or Flink. And then Java has been one of, if not the major language for big data in general. You can use Java and Spark. So these three are kind of the bread and butter. Now, there are other languages you can use. Not going to talk about them in specific detail, but you'll see me refer to them for edge cases, for specific use cases, how to use it. The next major thing that somebody should know as a data engineer is basic shell scripting. Shell scripting meaning, Bash, or for example, even PowerShell if you're a Windows person. Shell scripting is what allows you to automate certain data input, data output processes so that you don't necessarily have to run those commands every time. Cron is a way to then automate the automation, which is to put on a schedule, basic schedule. There are some really impressive tools that are just pure command line programs that you give it data, you give it a configuration, and it spits out data. And if you can help it, you want to use something like this because, why program something in 25 lines if you can just have a one-liner that gets you what you want? I may just have a session on set and awk and JQ, because once you see what these things can do, it's going to blow your brain, in the sense that it changed my worldview of what these programs were about when I could do something in 3 lines, not even 3 lines, basically one line command was used to, let's say, extract data from one file, Another section of the script was used to basically concatenate it, and then the third one was to cut it into different files, and I could do that in just with one line in Unix. Databases, this is by means not a comprehensive list of databases, but as you can imagine, data engineering is about knowing databases. Databases are at the center of data engineering, and databases come in all different types, all different sizes. The main kind of core bottom of the foundation level knowledge is that you need to know relational databases, you need to know non-relational databases, you need to understand what data lakes are, and then actually you can put in here what a data warehouse is or a data mart, right? So actually, I'll just simply call this net storage. And then modeling. How do we model structured, unstructured, or semi-structured information? Why do we need to have an understanding of these different types of data models? Frankly, because one of the tasks in data engineering would be to take raw data that is coming in as structured, unstructured, or semi-structured information, process it into one of these formats, and to do it in one of these potential databases or in this type of different storage mechanisms of information. Data processing can be done in a variety of different ways. Yeah, let's go ahead and put this under like target or source databases. But data processing involves batch, stream. Essentially, everything falls into there. Batch, stream, or microstream, or microbatch, whatever you, well, not microstream, batch, stream, or microbatch. And you can do microbatch in Spark or Flink. And then there's a variety of different stream processing frameworks as well. These are just the most popular ones. These are all Apache projects. You don't have to use all Apache. You can use different technologies for data processing. In fact, I would even say shell would be a type of data processing. Here we can do setup. You can do Python here. You can do even Perl. Perl was the original gangster in data processing. So it was a very powerful language for text processing, very powerful. Once you know how to program, script it, understand data, understand how to process it, then the next level, and by the way, most people stop right here, right? Most data engineers, they stop right here because they figure they know how to program, they know how to automate their program, they understand different data sources, and they understand how to get data in and out. They just stop right there. And that's fine, but pro-grade people will go to the next level, which is how do I use a more robust scheduling engine? Because in a production system, well, some of our clients use cron jobs to schedule their jobs, but that's really not the best way to do it. There are better tools to do that. And there's, for example, Airflow. Airflow is made at the Airbnb. It basically allows you to create sequences of data engineering processes, data science processes in a pipeline. Jenkins, even though it is used for building software for CI/CD, it can also be used for scheduling jobs in a similar way that cron is used. And it can tell you if a job failed or if it succeeded. AutoSys is a very expensive commercial component that really large companies use to run jobs, but there are alternatives. If you look for, let's say, AutoSys alternatives, there's a bunch of different alternatives. Quartz is a library in Java and in C#, where a program can use a database as a backend for a schedule, and that schedule looks very similar to a cron table in Unix, but Quartz interprets that what is in the database and it runs your jobs for you. Spring Data, Spring Batch, Java, Spring has a lot of really amazing libraries for data processing. I would say data processing here, let's just say for pure batch, here's simply Spring batch. And I think even in here, you can have something called Spring data. It has some components to it. But you can use these tools to do some basic scheduling as well. For example, to put your schedule in a table and then you use Spring, just a Java program to read from the table and to run it. And then finally, there's cloud data scheduling. So if you Google like cloud cron or cloud scheduling, each of the different systems has ways to set up a schedule to run things for you. Some of them are better than others. But that's the next level up. Again, most people here will stop and say, well, I already know how to run my job and schedule it. I'm good. But if you want to go again, learn some more, what you should do is really understand how to do that in all the different clouds. And to understand how does a program or a system of programs run on these different clouds. So if you're a data engineer, at this point, you not only understand database administration, what databases to use, how to get data in, how to get it out. Now you're starting to think like a cloud operator. And now you're starting to think as a data operations person where different technologies from these native clouds could be used for data engineering. So AWS, for example, has S3 for data storage, one of the best data storage engines in the world. But there's also something called DMS, data management services. At first glance, you're like, why would I use AWS for this stuff? Well, if you go dig deeper, you'll realize like you can basically extract, translate, and load data in this GUI tool and specify like all these amazing things like get data from this database and only load it if it changes, for example. So if you could help it, why wouldn't you use a magic tool like that in your processing, right? Google now has something called DataProc. DataProc is basically like Elastic MapReduce. So Amazon Elastic MapReduce is basically a managed Hadoop / Spark. DataProc is kind of the same thing, right? And then Azure has Azure Databricks. It also has something called HA Insight. So what these clouds offer is not only native storage that is very, very fast, they also offer different streams, different processing. Nowadays they have serverless functions. But the biggest thing that they could offer to a data engineer is the actual core data engine of storage, and as well as the data processing engine. Actually, I'm working on a paper which compares all these different options, but if you can help it, why would you run your own Spark? If you could just say, I want a cluster to run this job and then go away, right? And finally, even though I would say this is pretty advanced level knowledge, the real program people understand how to build everything with code. So infrastructure as code, right? You have Terraform, you have Ansible to then manipulate the system and it's up and running. And then if there are any services, any APIs, any Spark jobs that you would containerize, you would use something along the lines of Docker or Kubernetes to then run those systems. At this point, you've kind of touched the sky in terms of what you're doing with data, and you're really breaking the atmosphere with, okay, now I'm a data architect, okay? Because after you understand data engineering, now you're basically creating data platforms. There are always new things that are coming and going, and so a really good data engineer, data architect, data platform architect would be understanding what the pros and cons are for those. So some of the new things out there are, for example, serverless functions, as well as, let's see, DataLink. And then there was something that I just looked at it this morning. There we go. So there's something called Apache Koalas, or it's called Koalas. And Koalas is basically the Pandas API on Apache Spark. Who knew, right? And there's always new stuff coming out. Both Delta Lake and Koalas are from Databricks. It's, not necessarily an Apache project, but use what's available to you, right? Okay. Any questions so far about the general roadmap before I get into some of the guides that are available for you to kind of dig deeper into this? Okay. All right. So I found a few different guides, as you can see, a bunch of them. I'm going to give you a quick review of a few of them and give you my, honest assessment of how good they are versus how, skewed they are for a particular type of data engineering. I think you should get a handle on these different types of data engineering roadmaps so that you understand where you are at. A data engineer that focuses on helping data scientists is different than a data engineer that works on helping, platform engineers that are building like an API, right? They still need data engineers. Their data engineering needs are slightly different. This is a Medium blog post right here. I think it's one of the better ones, and these things are fairly timeless. But it talks about data engineering. It refers to various different topics. But one of the things to understand is that data engineering did not start with data science. It just became much more pronounced as a separate field. Data engineering was just a part of software engineering before this. And there's an area of overlap between a data scientist and a data engineer, which is that you have to know, basically analysis, data analysis. You have to understand what data looks like, how to query it, all of that. In order for you to be able to produce the right information, you have to know how to query it. Lots of different technologies out there. Again, this is just one, explanation of data scientist versus a data engineer. Data scientist is driving the engine, driving the car to understand what's going on, whereas the engineer is kind of building the race car itself. That's one good example. The other good one I like is, let's say, here we go. I think the DataCamp one was good. Yeah, I like the DataCamp one a lot. And the reason I like this one is it has this like visual explanation. In fact, this is what I used to kind of map out my outline, and I added to it. But become proficient at programming, learn automation and scripting, blah, 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 all the way down to keep learning. And like it gives you references, explains cron, for example. So if you're really, really new at this stuff, it'll help you. But I think that the value of this particular article is kind of, oops, that's not what I want to show you. That's an advertisement. Was this, which is the data and AI landscape in 2019. And actually, that's 2019. So 2020 is even bigger. So, here's a quick thing, right? If you look at this, this logo wall, and you understand like 10% of the logos and what they do, you're like intermediate, right? If you understand 25%, you're like a master level person here. If you understand 50% of what's here, like you should be, or even more, you should be like a CIO at a Fortune 500 company, because there are so many different tools, and big companies actually use all of these different tools for various different things. So for example, Cloudera and Hortonworks are now the same, right? So in terms of technology, you should know what the technology is, but you should also kind of know which is old information. MapR is not exactly Hadoop, but it has Hadoop-like stuff. HD Insight, that's what this is, Microsoft Azure, Google Data Proc here, AWS EMR, and then we have Confluent, which is also Kafka. We have Strim, which is a different type of stream platform, Amazon Kinesis, which is kind of like Kafka, but it's not. We have Google Data Flow. And you see, as I go through this, there's always like some sort of commercial provider, there's some cloud provider, and if you go look at you'll also see that there's open source ones. So the knowledge of data engineering goes beyond just all those different skills that I just told you about. It actually goes to how does this all fit together? So infrastructure, AI, applications, and then here are the open source, and here are the data sources. I mean, outside data sources, for example. And the more you know about this, the more you'll realize that you have to continuously keep learning what's out there. These guides are going to be posted on a blog post. I don't think they put a recent digest out there, but I hope they keep going. Otherwise, we'll have to take it over. But Data Engineering Digest is a Medium publication where basically every month they have different resources. So, for example, what they talk about: Kafka update, Scala update, Flink update, different types of resources for, like, the role, the data engineering role, courses. There are a lot of summits that have put their videos online. So great resource. I mean, if you read the last 3 or 4 different digests and you read every one of those articles, you'll be pretty up to date. Question. Okay. I think somebody has hopped off. All right. And then there are, I didn't really get to expand this much, but there are very specific resources for data engineering on a particular platform. So like data engineering with Spark, data engineering with Informatica, or data engineering with Kafka. And each of them are basically a different style of doing something. All of this still holds true. You have to know all of this stuff before you can be specifically good at data engineering on a certain platform. And then we got our resources. I mentioned, I showed you this one already, but I found a few awesome, quote, awesome links, like we have Awesome Cassandra. And these are doing an okay job. I think they're mostly up to date. This one's no longer up to date, so that's why I removed it. And so I will delete this. Let me do this here. And so at a quick glance, here's awesome data wrangling. And this is actually, even though it's not a very big document, it actually is very useful because it explains to you that, hey, there's a tool that I can use to go from Excel to CSV, right? Why would I write a program if I could do that just for the program? Or example, JQ, command line JSON parser, which is amazing, right? Take data as JSON, put a query on it, and then get a different JSON. CSV processing, big part of data wrangling, data engineering is CSV parsing. So again, not amazingly comprehensive, but for the new person, even though it's a little old, it's worth it. And I'm gonna actually put this in my Toto because I might branch this, work this, and keep this up to date because people need this. People need a good data wrangling guide. All right. This page, it's probably as good as it gets in terms of like hand curated tools for data wrangling. And I haven't seen a similar project out there. But actually, here's something called Squawk, for example. So awk, where is the actual web page, dude? There we go. Nope. That's an ad, sorry. They make this so hard. Nope. Oh, boo. This website's not that great. I'll just have to Google Squawk. There we go. So awk is, a command line tool where you can give it structured data. You can say, get this field, do this with it, and output it. And so in this, you can actually do that with a database. And you can say, get this from the database, and then apply these awk attributes to it. Awk is a very powerful tool. Again, I would not have known about this unless I had gone to that guide and looked deeper. Awesome data engineering, pretty comprehensive. And as you can see, it covers a lot of those high-level things that I mentioned: database, getting data into the system, file system stuff, how to store data, stream processing, batch processing, BI, workflow management, data lake management, Elk. Oh, I love that. I have a whole section on Elk. Docker, data sets, monitoring, and then general community. Very useful. And then awesome open source data engineering, more specific, how to do all this stuff with just pure open source stuff. Same general outline. Let's say we have BI. It's a little bit different, but all of these can be recategorized into what I was showing you earlier. And we just covered this. All right. Cool. Did I miss anything? I think we went over all of this stuff. So, any questions for today? Nope. All right, guys. So we can wrap it up early, and let's go ahead and stop the recording.